The first experiment was the tensile strength experiment. For the tensile strength experiment, our prototype was hung from one end from a height using clips. On the other end, a plastic bag was attached with clips. We then added 50-gram weights into the bag. We kept on adding the weights until the prototype snapped. We did not have variables as our experiment was an observation and was not repeated. Problems that came up when doing the experiment, and some ways that we fixed them. One problem was that when we attached the material to the height using clips, we found that the clips were exerting a large pressure onto a small part of the material. Therefore, the material was more likely to get ripped. To fix this problem, we placed wooden ice cream sticks in between our prototype and the height and plastic bag to decrease the pressure exerted onto a small part of our material. Another problem we came across when completing this experiment was that we found it very hard to keep the thickness of our homemade material the same. However, unfortunately, we realized that we could only fix this problem if we had access to proper manufacturing equipment. Therefore, this problem will remain unresolved. The results for the tensile strength experiment. Our prototype was able to withstand 1 kilogram of weight. However, because we did this experiment at home, we ran out of 50-gram weights. Therefore, we concluded that our prototype could withstand more than 1 kilogram of weight. When completing this experiment, we learned that the thickness of the material affects how much weight that our prototype can withstand before they rip.
The second experiment was the impermeability experiment. We covered a cup in tin foil and laid the prototype on top of it. We poured water over the prototype and then removed it. After observing the volume of water that was allowed through, we could decide whether the material was permeable or impermeable. We did not have variables, as our experiment was an observation and was not repeated. We found that our prototype was impermeable, as there was no liquid at the bottom of the tin foil cup.
The third experiment was the flexibility experiment. For the flexibility experiment, we laid our prototype out flat and put a protractor against it. Then we bent half of the prototype against the protractor and measured every angle that the prototype folded until it broke. Again, we did not have any variables as our experiment was an observation and was not repeated. Results for the flexibility experiment. We found that our prototype was able to bend by 180 degrees. However, the flexibility can range from 1 degree to 180 degrees depending on the thickness of our material. The thicker the material, the less flexible it was. The fourth experiment was the protectiveness experiment. In this experiment, we turned the prototype so that it was upside down on the floor. Then we placed a plastic bag on it, adding 50-gram weights spread over a large flat surface area to spread the pressure out evenly on the bottom of the prototype. We kept on adding weights until the prototype gave way. Again, we did not have variables as our experiment was an observation and was not repeated. Results for the protectiveness experiment. We found that our prototype gave way after 500 grams. However, at this point we found that the thicker the material, the more weight it could withstand before it gave way. For example, another prototype that we tested gave way after 40 kilograms.